Welcome to part 2 of the substitution rule for integration. For our next portion here, we have integrals of symmetric functions, and this is meant to make the calculations a bit easier. If we could determine if the function is symmetric. So suppose f is continuous in a closed interval from -a to a. If f is even, then the integral from -a to a of f of x dx is 2 times the integral from 0 to a of f of x dx. Likewise, if f is odd, then the integral from -a to a of f of x dx is equal to 0. So the graph here on the left is an even function, right? And we could see finding the area under the curve. Since it's an even function, we are symmetric on the left side here and on the right. So it's the same thing as finding the 2 times one of the two areas. Likewise, this one here is odd, this function. We could see that between this left and right area, they cancel each other out. And so because of that, value of that's just 0. So, for example, we want to evaluate the integral from -2 to 2 of x to the 6th plus 1 dx. So if we put -x in for x in this function, this will be -x to the 6th plus 1. And that will just give us x to the 6th plus 1, which is the value of a function back. So this would be an even function. So because of that, so we don't have to deal with the negative terms, we could just take 2 times the integral from 0 to 2 of x to the 6th plus 1 dx. So that would give us 2 times, this is going to be 1/7 times x to the 7th plus x. And this will be evaluated between 0 and 2. So 2 times 128/7 plus 2. And if we subtracted the values at 0, since both of those terms are 0, it would just be 0 anyway, so minus 0. This will make 284 divided by 7. And then from our last example, we want to evaluate the integral from -1 to 1 of the tangent of x divided by 1 plus x squared plus x to the 4th dx. So here, if we were to put -x into this function, we would get the tangent of -x divided by, this would be 1 plus -x squared plus -x to the 4th. And that would give us negative tangent of x divided by 1 plus x squared plus x to the 4th. And so that is the negative of our function. So this is an odd function. And because of that, we could simply say then, without even having to go through the calculation, that this integral gives us a value of 0. Let me know if you have any questions or concerns. Thank you.